Okay, so from this triangle here, we can figure out all the angles. All right, so somebody tell me what this angle right here is, angle A, on the inside of the triangle, and how you figure it out. Anybody? What'd you say? 93, how'd you get that? Yeah, this is a straight line, very good. They're a linear pair. So 93 and 87 is 180 degrees. So that's 93 degrees there. All right. So now, what is this angle? Angle C. Calculate it.
Yeah,
2.8. 2.8 degrees. Okay, good. All right, so now we can set up our law of sines. So those of you who have been missing a little bit, law of sines is one side to the opposite angle. So we can do the sine of 50 degrees is to the sine of 2.8. Let me start that over. Sine of 2.8 degrees is to the opposite side, which is 50. And then we can do the sine of 84.2 degrees is to angle the other side, which is B. So you just set up a proportion and you cross multiply. That's what the whole lesson is. I'm going to be saying it every time we do this. So we take 50 times the sine of 84.2. And that is 4210. Make sure I did that right. Nope, that's not right. It's like can't be right. 49.744. 49.744, and that's equal to B times the sine of 2.8. So we're going to divide off the sine of 2.8. And everybody should get 1018.3 for B. All right? And then it's so wonderful that it wants to know the height of the satellite, the altitude of the satellite. So, again, we have B. We have another triangle here. Now that we've solved for this piece here, we can do this piece is to the sine of 87. And we have this side is to that degree there. Okay? Let me see what this is. Now that we've drawn it separately, do you see which trig function you can use now to solve this? It is a 90-degree right triangle. You can use SOHCAHTOA at this point. You have a degree given, you have the opposite side that you want, and you have the hypotenuse. Which trig function will you use? Sine, because the sine of 87 degrees is the opposite leg over the hypotenuse. And then you solve it algebraically. Okay? So sine of 87, or 1018.3 times the sine of 87. And it should be less than what B was. B is a diagonal to the satellite, and the altitude is straight up, so. So I know you're paying attention? No, you're not.
Yes, I am.
What are you doing? Are you really?
Yeah.
Okay, any other questions on this one?
We like taking videos.
Well, this is,
Even though he's-
okay, fine. All right, so this is number 33. Distance across a river. To find the distance across a river, a surveyor chooses points A and B, which are 200 feet apart. Okay, so we have this wonderful river going across here, okay? Woo. And points A and B. Point A on the other side of the river, point B on the same side, and then you have point C on the opposite side, making a triangle. Okay? So now, A and B are 200 feet apart. So then chooses a reference point C on the opposite side of the river and finds that BAC, angle BAC, is 82 degrees. And ABC is 52 degrees. Approximate the distance from A to C. Okay? So, if you're trying to see where your proportion is, you have this leg, so you need that angle. Otherwise, you can't do this. So what is that angle, and how did you figure it out?
I took 82 plus 52 and I subtract that from
Yeah, 180 minus 82 minus 52. 134, so what is that?
46 degrees.
46 degrees. Very good. All right, so now you can set up your sine function. So you have the sine of 46 is to 200, and it wants from A to C, right? Yeah, A to C. So this is little b then. So now we need that angle. So sine of 52 is to b. All right, now let's cross multiply. Did everybody do that? So b times the sine of 46 equals 200 times the sine of 52. Going too fast on my calculator. 157.6021507. And then divide off the sine of 46. And I get...
Hang on,
two-
give me 2 seconds. 19.09.
219.1. That's good enough.
Okay.
All right, that's all that is. That's not asking for anything else. Following? Hanging in at all? Okay. All right, let's go on. Next one. Let's just keep going now that you kind of see how we're doing this. Some of these are a little more difficult than others, but really all you're doing is subtracting and adding. Yeah. Oh, yeah, definitely. Okay. Next problem. Which one did you have here? The Leaning Tower of Pisa, right? Yes. I've been there. Has anybody else been there?
Where?
Leaning Tower of Pisa. Nobody?
I watched
Isn't it like slowly straightening now?
No.
I feel like I've seen it.
No. Yeah, it's pretty cool looking. It's a lot bigger than what I thought it was. All right, the bell tower of the cathedral in Pisa, Italy, leans 5.6 degrees. So here it is, 5.6 degrees. Okay? A tourist stands 105 meters from its base. And with the tower leaning directly toward her, she measures the angle of elevation to the top of the tower to be 29.2 degrees. Find the length of the tower to the nearest meter. All right, so we'll just say A, B, C, and we'll call that little b. It wants to know what little b is. Okay, again, this is the only leg given, so you have to have that angle. How do you find the angle again?
Add 'em up.
Yes, 180 minus 5.6 minus 29.2.
145.2.
That's right.
Let's go.
145.2 degrees. Okay, now we can set up our proportions with sines, law of sines. The sine of 145.2 is to 105 as the sine of 29.2 is to little b. Everybody calculate that, please. Wayne, what is it?
89.76.
Very good. You're going to beat me on this one. Okay, whatever. All right, so this is the calculating distance. So we have a mountain, okay? And there's a hot air balloon, a really cool hot air balloon. Woo. Hot air balloon up there. And so two observers at P. And at Q. Okay, P and Q are located on the side of a hill that is inclined 32 degrees. So the hill is inclined 32 degrees. That's what's important behind this one. The observer at P determines the angle of elevation to a hot air balloon to be 62 degrees. So angle of elevation, so here we go. This whole angle right here is said to be 62 degrees. At the same instant, the observer at Q measures the angle of elevation to the balloon to be 71 degrees. So the angle here, this big angle, is 71 degrees. Okay? If P is 60 meters down the hill from Q, so 60 meters from P to Q, find the distance from Q to the balloon. So we need little p here. All right. Now, you had to understand angle of elevation was from a horizontal. It's always from a horizontal. So, that being said, this is 32 degrees here. This is 32 degrees here. That's the angle of elevation, or the angle of inclination of your mountain. So you now can figure out those angles of those triangles. So at point P, that angle, you take 62 minus the 32, that gives you 30 degrees. 71 minus 32 is 39 degrees. So somebody tell me what this angle right here is. And how do you know?
It's 111 because you took 180 minus.
Yeah, because this is a straight line right here. They're a linear pair. So 180 minus 39, oops. So 141. Why'd you say 111?
Oh, I thought we were taking topic.
All right, so now, again, what I've said before is this is the only side given, the 60. I need that angle to do the law of sines. So now you have the interior angles. Tell me what that third angle is. What'd you get? All right, so we're going to write that down as 9 degrees. And now we can set up our law of sines. Okay? That's little p. All right, now cross multiply and solve it. Any questions?
Yeah.
What's your question?
I don't understand what all the extra stuff is.
All right. So p times the sine of 9
Is that what you got?
and 60 times the sine of 30 is 30. All right, sine of 30 degrees is 1/2, isn't it?
Yep.
Half of 60 is 30. Divide off the sine of 9.
I got it. I'll put
30 divided by the sine of 9.
So there's 1.77 meters.
Good. Any other questions on that one? All right, keep going. What problem was that, by the way? 37. I forgot to write it down. And the last one, 39? Oh, that was 39? Oh, I'm sorry. I skipped 37, didn't I? Sorry. So this is 39. Oh, it's recording. All right. Oh my gosh. 37. What was this? Height of a tree? Oh, really? A tree on a hill casts a shadow 215 feet down the hill. All right. Here's your hill. Here's your stupid tree. Tree. Oh, I'm sorry. You gotta have a tree. It's this high. It casts a shadow down the hill 215 feet. If the angle of inclination of the hillside is 22 degrees. So this right here is 22. That's the hill. The hill is 22 degrees going up. And the angle of elevation of the sun, meaning the sun's right here. Woo. So the angle of elevation to the sun, meaning from the horizontal to the sun, that is 52 degrees. So this big piece here is 52 degrees. Find the height of the tree. All right, so we'll call this point A. So we need little a, B, C. So again, here's a problem. Here is the leg. We need the opposite angle.
Yeah.
Okay? And you're like, okay, well, I can figure out angle A. How do I get angle A? Or CAB is what I'm looking at. Angle CAB. How do you figure it out?
22 minus 52 is 30.
Yeah, 52 minus 22 is
Yeah,
30.
52.
So that's 30 degrees. Good. Well, there's a problem, right? But we can simply get it. So let's just draw this real quickly. Here's a horizontal. This is 90 degrees. All right? This is 22 degrees. Right? Oh. So what I want is this angle right here then. What is that angle?
68.
68 degrees. All right, and if that's 68 degrees, you have a linear pair here.
112.
So how do I find that?
180 minus 68.
180 minus 68 gives me 112 degrees. That's how you get the second angle.
Good job, man.
And now you can get angle C. So 180 minus 30 is 150, minus the 112 is 38 degrees. And now you can set up your law of sines.
Man, that's great.
Yeah, it is crazy, but you can't just use tape measures and stuff. You gotta be able to use some trigonometry for things that you just can't measure, okay? Sine of 38 is to 215, as sine of 30 is to little a. And that's what it wants, how high the tree is. Could just cut it down and measure it.
With a tape measure.
That's right. But you couldn't do that with the hot air balloon.
And nice person in there with the tape measure.
Got it.
What'd you get?
174.61.
That's right. 174.61. That's how tall that tree. That's a really tall tree. Yeah, that's correct.
Triangle thing.
Any questions?
Maybe you should just give our test.